So everybody's got your note sheets out. At the top there's an 11 with a circle around it. And then you see down the page 1.5. We are finding the inverse. Okay, everybody on note sheets, 1.5, right? The very first thing says find F inverse. This is read F inverse of x. That's how we say that, F inverse of x. The inverse is the function that undoes the original. So, the original is 2x plus 1. We want the function that's going to undo that. Now think about it. If you put a number, let's put the number 3. If I put 3 into this function, what happens to it? What happens to the 3? It gets times by 2 and then added 1. 3 times by 2 and added 1. Now, think of it as a machine, as an operation. It times this by 2 and adds 1. Now, put that machine in reverse. Undo that. What's going to have to happen? Subtract 1 and divide by 2. So the inverse is the function that subtracts 1 and divides by 2. Now, let's see how that works. Let's go ahead and put our 3 in. If you put a 3 into this function for x, if you let x be 3, what does y end up equaling? 7. Now, take that 7 and put it into this new function. What happens when you put 7 in there? You get 3. See what happens? It undid it. Notice that the x's and the y's got switched. If you like to, if you say, oh, Miss Ford, this is just a little bit foggy, man. I'm still not real sure where you came up with this. There's a way to do it with paper and pencil, not just in your head, but with paper and pencil. Let's go through the steps. If you take the original function, here it is, the original function, and you switch the x and the y. Now, don't be confused about that step. What happens in inverses? The x's and the y's get switched. So I switch it. Now let's get y by itself. So we'll subtract 1 and divide by 2. Look what we came up with. So the first time through, I kind of just did it in my head intuitively. This time, I actually went through some steps. So if you like rules and you want to write things down, this is how you do it. So what did I do again? What was the first thing I did? Switch my variables. And then what's all this? Getting y by itself, solving for y. Okay, let's try the next one. Now we'll do it both ways. Think about it as an undoer. What does this function do? What operations happen in this function? If you put a number in like 7, what's this going to do? It's going to times by 3, and then subtract 1, and then divide by 2. So think about it as a machine. Times by 3, subtract 1, divide by 2. Now put it in reverse. What's it going to do to undo that? It's going to multiply by 2 first. And then what? Add 1. And then what? Divide by 3. That's the answer. But if you're confused about that, let's go through these steps over here. here's the original problem. So what did we say? What was the first thing we had to do if we're going to find the inverse this way? The first thing is switch your x's and y's. Now, you got to get this alone. So, what will we do first? Multiply by 2. And then add 1. And then, and lo and behold, look at what we got. Same answer we got when we did it in our head. I don't care which way you do it. Now the hard problems, we're going to have to do that way. But these simple ones, if you want to do it in your head, that's perfectly okay. All right? Now let's go back. Just for fun, let's stick a 7 in here. What do you get if you put 7 in there? Into the original problem, put in 7. What do you get? Which is 10. You get 10. Now, I'm going to put that 10 in here. What do you think's going to happen? If I put 7 in and got 10 in the original, what's going to happen when I put 10 in the inverse? I better get 7. Do I get 7?
Yeah.
That's like a little check, isn't it? They have to reverse each other. They have to undo each other. If 7 gives me 10, then 10's got to give me 7 every time. Next, try C on your own. Either do it in your head or do it with the steps. It doesn't matter, whatever you're comfortable with. See if you can get the inverse for C. Anybody want to share your answer? What did you get for the inverse? And let's use this notation, Jake.
I have a 9x plus 2 over 4.
What do you think, kids? Did you do this by hand, or in your head, or by hand, Jake? In your head? Okay. Let's talk about this, because this is an easy mistake to make. In the original, we're timesing by 4, adding 2, and dividing by 9, right?
Yeah.
Now we need to undo that. So think of it as a machine. Okay, now put the machine in reverse. So the first thing that we're going to do is times by 9. What's the second thing we're going to do?
Yeah, actually, I said it wrong. I actually had it right on paper.
This should be minus,
Yeah.
right? And then divided by 4. Now it's correct. Would you agree with him now? All right, look at the next one. Little curveball here. It's kind of hard. Let's switch our variables and do it on paper to make sure we get everything done in the right order. This is a little tricky. So if we're going to do everything in the right order, let's see. What would I do here? Oh, switch my variables. Okay. Now my variables are switched. I have to get this guy by himself. What am I going to have to do to make that happen? I have to square both sides. Does it make sense to you that we would be squaring both sides if we're talking about the inverse? Yeah, because if the original square roots, the inverse is going to have to square. But there's one more step. What will be the last step? Don't subtract 2. Add 2. So there is your inverse.
Will we get points off if we keep it as y? We need to look
Probably
right
not.
now.
Okay? All right, now we're ready for D. This is a GTQ guaranteed test question. Might even be a GQQ, guaranteed quiz question. All right, what's step one? Well, first, if I'm doing an inverse, I need to switch my variables, right? So x equals 2y plus 1 over 3y minus 4. That step's important. Don't forget to do that first. Jordan, want to put your head up, honey? I know, but put your right with your head up, please. If one of my bosses walks in and your head's down, I will get in trouble. You don't want me to get in trouble. Okay, now, what am I going to do next? Remember, you're trying to solve for y.
Is
So
it y
what?
by itself?
Well, how do I get y by itself?
By 2 times everything by
Yes? By something. What? We're to multiply this denominator over here to this side so we don't have a fraction anymore. No, I'm just multiplying it over. Bringing this over here so I don't have a fraction anymore. Okay, so I brought my denominator over, multiplied it over. Now what, just look at it now, kind of the next step makes sense. What do you think is going to happen now? What do you think is going to happen? Distribute. So now we're going to distribute. Now what's our focus? What'd you say, Erica? We're trying to do what? Get y by itself. So what I'm going to do now is I'm going to put every term with a y on this side and every term without a y on this side. Okay, so I'm just going to rearrange. So if you have a y, you're coming over to the left. If you don't have a y, you're going over to the right. So here we go. Ready? I'm going to subtract the 2y, and I'm going to add the 4x. Now that's not hard, that's rearranging. I'm moving things around. And how am I moving things around? If you have a y, you're coming to the left. If you don't have a y, you're going to the right. Now that I have all the y's on the same side, I'm going to factor out a y. So what will I have left in my parentheses if I pull out a y? Okay. Now my goal is to have y by itself. So I'll divide by that. And your answer, kids, is right here. This is your answer. Your inverse is 4x plus 1 over 3x minus 2. Now there's another one there. We're going to do it here in a second. Let's review these steps. Okay, what was the very first thing I did? I switched my variables. What was the second thing I did? How did I get this ball rolling? I took my denominator and multiplied it over to the other side, right? Then what did I do? Distribute it. Then what did I do? Move things around so that y's are all together on one side and non-y's are on the other side. Then what did I do? Well, I factored out a y, and then I divided. Okay? So what I want you to do is try F right now and just redo the steps that I did. It's exactly the same kind of problem. Redo. Lindsay? Would I simplify? Just take y out. Yeah. Always just factor out y. Because your goal, Lindsay, is to have y equals, not 2y equals, but just y equals. Did everyone start by switching the variables? Okay, that needs to be written on your paper at the beginning somewhere. Erica?
Does it work to like take out like a 4y?
So that was Lindsay's question, and certainly if you can take that out, you can, but I wouldn't do it, Erica, because your job is to get y by itself, not 4y, just y. So even if you factor that 4 out, you're still going to have to divide it, so it's easier just not to factor it out. All right, so everybody got this variable switched. Zach, what's the next thing we do after we get our variable switched?
You make x, wait, don't you divide 4y, well, you bring the 4y plus 1 over.
There you go. I bring the 4y plus 1 over, so I'm going to multiply those sides by 4y plus 1. Good, Zach, good. All right, Connor, what happens next? Once I get that 4y plus 1 moved over, what do I do now? Distribute. All right, very good. Thank you, Connor. Absolutely perfect. Franny, what happens next? I did the distributive here, like Connor suggested, so here I am. What do I do now?
Now you look at switching to 8y,
So I rearranged the equation, just moving things around in the equation so that everything with a y is together on this side. Brittany, what happens next? I take out a y. So again, several of you have noted, you can actually take out more than just y, but just take out the y. Because what's your last step? To get y equals, right? We want y by itself. So how many of you got this as your answer? Good. Good.
I have 4x minus 8 at the top and negative 1x minus 2 on the bottom.
I don't know. Did you have this step?
Yeah.
Okay, well, this is what you're dividing by because you're trying to get y by itself. So you have to be dividing by that. Okay. We'll practice another one of those at the end of the period if we have time. If not, we'll do it tomorrow because that's definitely going to be a test question. Okay, let's look at part 2. We have 3 questions to answer about each of these pictures. The first one is a no-brainer. You already know how to do the first one. Is it a function? A, Yes. Yes, it passes the vertical line test. Remember, A is a function because when you draw in vertical lines, none of them hit more than once. Look at B. Is it a function? No, because when you draw in a vertical line, it hits twice, right? How about C? Is it a function? Yes. So is everybody clear? A is a function, C is a function, B is not a function. Everybody good? And how did I know that? It passes or doesn't pass the vertical line test. Right?
Yes.
All right. Now the new stuff. Number 2. Is its inverse a function? Now, for the inverse to be a function, if inverse is a function, it has to pass the horizontal line test. So look at question A. It passed the vertical line test. We already talked about that. It's a function. Okay, good. But it does not pass the horizontal line test. Would you agree with me? Which means its inverse is not a function. So for question A, 2 is a no. That's my phone. I've got to turn it off. 2 is a no because it does not pass the horizontal line test. Now what about B?
Yes.
Its inverse is a function because it passes the horizontal line test. And so is C, because it passes the horizontal line test. Okay? Now we've got a new vocabulary word. 1-to-1. A 1-to-1 function is one in which no x's repeat, vertical line test works, and no y's repeat, horizontal line test work. So in other words, you can only be 1-to-1 if you pass both tests. So is A 1-to-1? No, because it passed vertical but failed horizontal. So it's not 1-to-1. How about number B, or letter B? No. It failed vertical but passed horizontal. What did I see? Yes, it passes both tests. Let's look at our cubing function. It's called 1-to-1. So what if the question said, is the cubing function 1-to-1? Visualize the cubing function, guys. Does it pass vertical? Yes. Does it pass horizontal? Yes. So the answer to the question is yes. What if it said, is the sine function 1-to-1? Well, see, you've already got it. You've already got it. Is sine 1-to-1? You say no. Why not?
Because it passes
It passes the vertical, but it does not pass, look at this. It does not pass horizontal. So the question would be, is the sine 1-to-1? You would say no, and I would say why not? And you would say because it does not pass the horizontal line test. Got it? One more. We have to get through number 3, and then we'll be done for the day. Sketch the inverse. Now, this is super simple. If you remember, one thing that I kind of casually stated a minute ago, or a few minutes ago, I'm drawing the original here. Does anybody have any idea how I would graph the inverse? This is the original, and I am now going to graph the inverse. Anybody, oh, I heard somebody say it.
Flip it.
Flip what? The coordinates. Remember what we talked about before? If we put 3 in and got 7, then what had to happen in the inverse? 7 had to give you 3. Remember talking about that, kids? So all I'm going to do is switch these ordered pairs. So let's start right here. What are the coordinates of that point? 1, 2, 3, this is -4, 0. So when I do the inverse, I'm going to plot it at 0, -4. You just switch the ordered pairs. That's what inverses do. X's become Y's. So what's this one? -3, -1. So where's it going to get plotted? No. You just switch them. You don't change your signs. You just switch them. So it's going to be -1, -3. This one is -2, -1. So -1, -2. This one is -1, 0. 0, -1. I'm going to connect what I got so far. It was a trapezoid thing like this. Is it still a trapezoid thing? Yeah. Yeah, but it's faced in a different direction. Okay, what are the coordinates of this point? 0, 1, so I'll plot it at 1, 0. Uh-oh, what's this one? 1, 0, so it's going to become 0, 1. And, uh-oh, look at this one. This is interesting. That point's 2, 2. What happens? It just stays 2, 2. And the last point is 3, 0, so it will be 0, 3. Do you see a similarity, at least, between the inverse and the original? Yeah, the shape's the same. It's just rotated or switched a little bit. You with me? Try the last one. Oh, it's much easier. Try that one. Try B. Draw B, the inverse. Anybody get something that looks like this? Everybody good with that? learned a lot today, good job. You got an assignment in your book. So, there you go. Remember, we have a